Hello guys, welcome to another lesson on logarithms, and kindly before I start, subscribe to my YouTube channel so that you can always learn from here. Alright, so today we are looking into logarithmic equations and expressions, and we are going to have first of all the rules of logarithms, starting with the rule number 1, the product rule. And the product rule states that when we have log a of x, log x base a plus log y base a, this is normally the same as log xy base a. So basically, in addition, for the product rule, here you can see we have addition sign, but when you combine the two, the first one and the second one, you will be like you're doing multiplication. So you will have log of x multiplied by y, then base a. That is for number 1 on the product. Rule number 2 on the quotient rule. Quotient means division. So basically, when you have log x base a minus log y base a, this is the same as log x divided by y base a. So for the quotient, you're seeing here we have division, but when the two of them are separated, it's minus sign. And for the product rule, the two of them here are multiplied, x multiplied by y, but when each of those terms are on its own, the two of them are being united by an addition sign. Whereas for the quotient, it's division on one side, and when we have the two terms, we have the minus sign. Rule number 3 on the product on the power rule. For the power rule, we have log of x power n base a. This is normally the same as this. The power, we can bring it on the front, and then we have log of x base a. The number 4 on the identity, and for the identity, this is log of any positive number to the same base. The base of that same number is always 1. So we have log of a base a is equals to 1. So it's log of a, and the base is still the same as that number. So such kind of a log is called identity. We apply here the identity rule, and this one is always equal to 1. And when I transform it into index notation, I can have this one is the same as a power 1 is equals to 1. And something else that you shouldn't forget is about the a power 0, which is equals to 1. Anything raised to power 0 is always 1. And this one is in index notation. When you change it into logarithmic notation, you will have log 1 base a, which is equals to 0. This is something which is very, very important to note. Yeah, so basically those are the 4 rules of logarithms, and you will be applying them over and over again while working out things to do with logarithms. So let's look into examples now. Example number 1. Examples. Example number 1, we have log of 8 base y is equals to 3. We want to solve for the value of y. Find the value of y. So here, basically this one, you just check the question the way it is, and then first of all think whether this is kind of a question that you have to change from logarithmic notation to index notation and then solve, or whether you are going to apply the rules of logarithms, or even the rules of indices. So for this one, we can see we have to change it into index notation. And in index notation, this one is the same as y. We said this is the base and this is the index. So in index notation, this is y power 3 is equals to 8. And we want to solve for the value of y. So this means that we have to express 8 in such a way that we have a base and then a power. So I can just automatically say that here the 8 is the same as 2 power 3. But if you want to, know how we've arrived into that, you can look into all the factors for 8. And if we divide 8 by 2, here we'll have 4. And if we divide 4 by 2, we'll have 2 and 2. So this is same. 8 is the same as 2 power 3. We have 2. All of them are 2's. And how many 2's are there? We have 3 2's. So that's why we have 2 power 3. And therefore, here we'll have y power 3 is equals to 2 power 3. And therefore, these 3 cancels with this one. The 2 of them are on top. All of them are in powers. We have y power 3, we have 2 power 3. So the 2 cancel, and therefore your y is equals to 2. You remain with 2. Right. Example number 2. For example number 2, we have log x plus 3 base 3 is equals to log 27 base 3. For this one, you can see here we have log base 3, we have log base 3. So the 2 of them are the same, so we can automatically decide to cancel the 2, and therefore we remain with x plus 3 is equals to 27. We want to solve for the value of x, and therefore our x is equals to 27 minus 3. X is equals to 24. Example number 3. Example number 3, we have log p squared base 4 is equals to 2 log 5 base 4. So, alright, so using the laws of the rules of logarithms, I think we can transform this using the power rule and transform it so that we remove these 2 from here. And therefore, we'll have log p squared base 4 is equals to log 5 base 4, and this one is 5 squared. The 2 we said, remember, whenever we have log x power n base a, this is the same as n log x base a. So it's just the same. We had these 2 here, and then now we bring it up there. That's why we have the 5 power 2. This one is the same as this. Log base 4 is the same. And therefore we remain with p squared is equals to 5 squared. The square and the square are the same, and therefore p is equals to 5. As simple as that. Example number 4. For example number 4, we have log 12 plus 3 log x is equals to log 96. When you see just log without the base, you can't see any base, whether it's base 2, base 3, when base 4, or whichever. You just see log. When you see this one, it automatically means this is log base 10, the one that you normally have in your calculators. So in solving this, we can use the product rule to combine these 2, right? And product rule says that when we have the 2, we can multiply 12 multiplied by, even before that, before we even multiply, we can transform the second term. Let's transform the second term where we have the 3 log x, and this one is the same as log x power 3. And therefore, here we have log 12 plus log x power 3 is equals to log 96, right? Now we can use the product rule, and therefore here we'll have log 12 multiplied by x power 3 is equals to log 96. Here again we have log 12 x power 3 is equals to log 96. We can cancel this log and this log, and please remember always when you are doing the cancelling, when you are cancelling maybe the log and the log, always ensure the base is the same. Whether it's log base 10, the other side should be log base 10. If it's log base 2, the other side should be log base 2. The base should be the same. And then how you can cancel, therefore we remain with this and this. So we have 12x cubed is equals to 96. We can divide both sides by 12, and therefore we remain with x cubed is equals to 8. So what is the value of x? Let's see how to change this 8 in terms of a base and a power, and therefore this one should be 2 power 3. And this 3 can cancel with this one, and therefore the value of x is equals to 2. Hope we are together up to there, right? Okay, so let's look into example number 5. Log y base 5 plus log y plus 2 base 5 is equals to log y plus 6 base 5. All right, so directly we just apply product rule for these two terms because it's the same log base 5, and we have y multiplied by y plus 2, which is equals to log of y plus 6 base 5, right? Log base 5 y squared plus 2y is equals to log 5y plus 6. This is the same as this, so we can cancel, and therefore we have y squared plus 2y is equals to y plus 6. Can we solve for the value of y? I can see a y squared somewhere, so this one is a quadratic equation already, and therefore this is y squared plus 2y minus 6 is equals to 0. That's a quadratic equation. Y squared plus y minus 6 is equals to 0. We already did solving quadratic equations either by completing the square method or even the quadratic formula, and I'm going to leave the link to those videos so that you can watch on how to solve quadratic equations. And here we are going to use the factorization method. For me it's fast and easy. So we have y squared minus y minus 6 is equals to 0. In factorization method, we normally say, assume you have two numbers, m and n, and when you multiply the two, you get the value of m multiplied by c. But when you add them, you should get the value of b. So first of all, let's identify what is our value for a, our value for b, and our value for c. Our value for a is 1, our value for b is negative 1. Don't forget the negative sign. And our value for c is negative 6, right? So from there, how do we proceed? We have y squared. Before we even proceed there, we ask ourselves, which are these two numbers? When we multiply them, we get m multiplied by n, we get minus 6. But when we add them, we get negative 1. These numbers should be minus 3 and 2. So now to proceed from there, we have y squared minus 3y plus 2y minus 6 is equals to 0. Combine these two, and those two you pair them. What is common between the two? Y into y minus 3 plus what is common between 2y and 6? Y minus 3 is equals to 0. And when you get here, you can even confirm whether you are right by removing the brackets again and see whether whatever you have up there is the correct thing. Y multiplied by y is y squared. Y multiplied by minus 3 is negative 3y, plus 2 multiplied by y is 2y, plus multiplied by a minus is a minus, and then 2 multiplied by 3 is 6. So you are right. Okay, and these are the same, so you just take one of them and then you combine this and that one. So we have 1 plus 2 and y minus 3 is equals to 0. To get the values of y, we have our first y from this one, we equate to 0. y1 is equals to minus 2. And our y2, we should get it from here, y minus 3. y2 is equals to 3. So therefore, our y1 is equals to minus 2, while y2 is equals to 3. And you are done. So we are done for today's lesson. Thanks a lot for watching. Kindly subscribe, comment, share, and like. Till next time. Bye. Thanks.